Multiplication and division of polynomials is the name of the game today. We're going to start with multiplication of polynomials. Remember that when we talk about polynomials, we're talking about monomials, which is one term, binomials, which is two terms, trinomials, which is three terms, and anything with four or more terms we just talk about as a polynomial. Also remember that we have discussed a lot of exponent rules. The rule that's going to be important in this scenario is that when we have x to the n times x to the m, it's the same as adding our exponents. So when we multiply like bases, we add our exponents. So for example, x squared times x cubed would equal x to the fifth. Okay. Now, previously you multiplied two polynomials. You probably just didn't realize it. You actually multiplied two monomials when we looked at exponent rules before. So for example, negative 3xy squared times 5x to the fourth y to the fifth was multiplying two monomials. And when we did that, we multiplied our two coefficients, negative 3 times negative 5, and we multiplied x times x to the fourth, and we multiplied y squared times y to the fifth. In doing so, remember that your x is really like x to the first, and we added our exponents, and we multiplied our coefficients, and that left us with negative 15 x to the fifth y to the seventh. Okay. Take a look at this example. In this case, we would multiply 8 times negative 4, which is negative 32. We would multiply a to the fourth times a, which would give us a to the fifth. 4 plus 1 is 5. We would multiply a to the fifth times or b to the fifth times b to the eighth, which is b to the 13th. 5 plus 8 is 13, and our c just stays c. Now, in this next case, notice that we're not just multiplying two monomials anymore. We have a monomial times a binomial. In this case, we have to multiply the monomial by everything that's inside the parentheses. In order to do that, we're going to have to distribute. We have to do 2x cubed times 5x squared and 2x cubed times negative 6. At this point, it's like we have two little mini problems. Okay? And we're just going to apply the exact same rule we did before. We would do 2 times 5 and x cubed times x squared. And remember, when we multiply like bases, we add our exponents. And we would do 2 times negative 6, and our x cubed would just say x cubed. Our end result would just be 10x to the fifth minus 12x cubed. Okay, this time we have a monomial times a trinomial. Same exact process applies, but instead of multiplying to two terms inside parentheses, we're going to multiply to three terms. So we have to do negative 7p squared times 2p squared, negative 7p squared times 5p, and negative 7p squared times negative 3. Okay. Again, we're going to apply the same rules at this point. It's just like we have three little mini problems instead. Negative 7 times 2 and p squared times p squared. And when we multiply those p bases, we add our exponents. Negative 7 times 5 and p squared times p, again we add the exponents. Negative 7 times negative 3, and our p squared in that term will just say a p squared. That will leave us with negative 14p to the fourth, negative 35p cubed, plus 21p squared. Okay. All right, here's one for you to try. See what you come up with, pause it, and see if your answer matches mine. How's 7x to the fifth minus 28x to the fourth plus 35x cubed sound? Here's another one for you to try. Negative 4v squared minus 2v squared minus 9. See what you guys come up with. Then check it against mine. You have to be careful with your signs on this one, but you should have come up with 8v to the 4th plus 36v squared. Okay. Now, look at this next one closely. Unlike the previous examples where we just had a monomial out front, we now have a binomial times a binomial. Okay? When we have a binomial out front, we have to make sure that the binomial gets distributed completely to the second binomial. So that means that the 2x belongs to the 5x minus 6, and the 3 belongs to the 5x minus 6. At that point, you can then distribute the 2x to the 5x minus 6 and the 3 to the 5x minus 6. I often refer to this as double distribution. Okay. This then yields 10x squared minus 12x plus 15x minus 18. And we end up with 4 terms in the end. Okay. However, notice that the negative 12x and the 15x are actually like terms. So we could actually combine negative 12x and 15x together to get a 3x. Now, there's also an expression called FOIL that a lot of people use to do a binomial times a binomial. It's kind of a shortcut to help them remember double distribution. FOIL stands for first, outside, inside, last. It's going to result in the same answer. It's just a quick, easy way of remembering double distribution. Okay, so the first would be 2x times 5x. The outer would be 2x times negative 6. The inner would be 3 times 5x. And the last would be 3 times negative 6. As you can see, we get the exact same result we got in the previous slide. It's just a nice acronym to help you keep the terms organized, and it's an easier way to remember how to do it. Okay. In the end, you still have to remember to combine those two middle terms, and you might hear me sometimes refer to it as the OI. The O and the I, the outer and the inner, will combine. Okay, so we still get 10x squared plus 3x minus 18 in the end. Okay, so here's another one, 3x plus 4 times 4x minus 1. Okay, the F, our first term here, would be 3x times 4x, which would give us 12x squared. The outer would be 3x times negative 1, which would give us minus 3x. The inner would be 4 times 4x, which would be plus 16x. And our last would be 4 times negative 1, which would give us negative 4. But again, we need to make sure that we combine our like terms here. Negative 3x plus 16x would combine to give us a 13x, and our final result would be 12x squared plus 13x minus 4. Okay. Here's another one. We've got 2x squared, 2x times 3x, which would give us 6x squared for our first term. Our outer is 2x plus 4, which would give us an 8x. Our inner is negative 3 times 3x, which gives us a minus 9x. And our last would be negative 3 times 4, which gives us negative 12. Combine those two middle terms, that OI, and we would get minus 1x. And so we get 6x squared minus 1x minus 12. Now remember, technically we don't have to write that 1 there, so we could just write 6x squared minus x minus 12. Okay. Try one of these on your own and see what you come up with. Pause it and once I determined my first, outer, inner, last, and combined my OI, I came up with 8x squared minus 38x plus 35. Thumbs up if you got that same answer. If not, try to go back and see where you went wrong. Alright, the next couple slides we're going to look at are some special cases of multiplying polynomials. Notice that when you look at 3x plus 5 times 3x minus 5, the only difference in these two binomials is their operator. That means that one has addition and one has subtraction. Now, we can technically go through these using FOIL, just like we did in the previous example, and we would get 9x squared minus 15x plus 15x minus 25, using first, outer, inner, last. Now, at that point, if we combined our like terms in the middle, that OI, we would find that negative 15x plus 15x is 0, and they would, quote-unquote, cancel out, and we would just be left with 9x squared minus 25. Okay. This is a special product called the difference of two squares. Notice that my answer here is the difference of two squares. 9x squared is a square, and 25 is a square. 3 squared is 9, and 5 squared is 25. And difference means to subtract. 4q minus 3 times 4q plus 3. Again, notice that these two binomials are essentially the same except for their operators. If we were to multiply them out using FOIL, we'd get 16q squared plus 12q minus 9. And we would find that those two middle terms, if we combine the OI, cancel out. And we would just be left with 16q squared minus 9. Again, this is a difference of two squares. It's subtraction, difference, and 16 is a square and 9 is a square. There is a general pattern that tells us if we have a plus b times a minus b, the answer will be a squared minus b squared. So if you have two binomials being multiplied that are of the same form, where the only difference between them is their operators, the solution will be a squared minus b squared. Okay. Now, a little side note is these two binomials are in the form of conjugates. That just means that their operators are reversed. Okay. Now, also keep in mind that technically we could also write this as a minus b times a plus b. And we would still get the same general form of a squared minus b squared. Okay, so keeping that in mind, if you can recognize a difference of squares right off the bat, rather than foiling it out, you can go straight to the result rather than taking the time to foil it out. Okay, now I always tell my students, when in doubt, foil it out, but if you can catch that shortcut in the beginning, you don't have to spend the time foiling it. Okay, now there's also a second pattern as well. Look at these two binomials. They are identical to each other. Okay, again, we could take the time to FOIL these. In this case, when we go to combine the like terms in the middle, notice that these like terms are not going to cancel. They're exactly the same. I didn't want a square there, I wanted a circle. These two like terms are exactly the same. So when we combine these like terms, they're actually going to become 9q squared, not 16. 9q squared minus 24q plus 16. Okay, so the relationship there between 12 and 20